Hello everyone, welcome to this special Unreal Engine episode. I'm Mamadou Babaei, the original author and maintainer of the SenseGlove Unreal Engine Plugin. Today I'm joined by a special guest, Apoorva Naronikar. Apoorva is an intern at SenseGlove. She joined SenseGlove a few months ago. Although she wasn't familiar with the SenseGlove haptics stack when she joined us, she picked up everything very quickly and successfully completed both her thesis and a demo showcasing how to build OpenXR-based hand interaction systems from scratch using the SenseGlove Unreal Engine plugin. Today, she is here to present her work, walk us through the Unreal Engine demo, and explain how she built it from the ground up. So, Apoorva, welcome. To get us started, could you tell us a little bit more about yourself?
Yeah, thank you, Mamadou. Like Mamadou just said, my name is Apoorva. I recently graduated from TU Delft with a Master of Science in Design for Interaction. My previous background is completely in computer science engineering and development. And so my goal for the future is to work where development and design comes together. And so I thought SenseGlove is the perfect place to bring in this creative mindset with new technology. And so I pursued this internship. Pleased to meet you all.
Thank you for introducing yourself so our audience knows more about you. Also, beside the demo that you did at SenseGlove, you had a thesis. Could you share with us what the thesis was about? Maybe provide a link so people could follow up on it if they are interested before we walk through the demo.
Yeah, of course. Just to give you a brief idea, the thesis was focusing on a research gap where there was no previous exploration on seeing a comparison between an environment with visual feedback and haptic feedback and an environment in virtual reality with only haptic feedback dependencies. So the task at hand was to study object size discrimination. And what this means is basically just seeing which object is smaller compared to the other given two objects. And so for this, I designed a VR environment which was minimal, simple, and of course you could find more in the TU Delft repository, which I will be showing now. This is the link where you can find the report in detail, and this is where I also have my abstract and the thesis report along with a small showcase video, which would give you an understanding of how the project progressed through iterative designing and multiple other limitations that existed throughout the process. If you go to the TU Delft repository and look for either Reach or my surname, which is Naronikar, you can find my thesis document along with the showcase video.
Yeah, thank you. So I guess now it's time to move on to the demo. First, maybe let me play back the demo. So this is the demo that Apoorva created at SenseGlove. It's completely from scratch without SGPON. For people who are familiar with the SenseGlove plugin, we have a system called SGPON, which is very limited. It's just like a simple system to help people get started very easily. But of course, as I said, it has its own limitations. That's why basically we documented the process, I guess, in our Unreal Engine 2.8, version 2.8. But also we wanted to do a demo for people to see basically how it can be done very easily using just the OpenXR data and bypassing the SGPON system. So you can definitely develop your own hand interaction system, animate a hand, create, grab, release, and do other kind of advanced hand manipulations inside the Unreal Engine, and also add haptics to it. So basically, this was the demo Apoorva has done. We are going to share this with you from basically 2.9, which is going to happen like probably in a week or so. The next release of our Unreal Engine plugin, we are going to put up this demo so people could download it. But of course, we have Apoorva who has done the demo. She's here to basically walk us through the demo. If you want to understand the demo and basically make modifications to it, probably this is an opportunity that we could use and ask Apoorva to walk us through the demo. So could you please share the demo with us and maybe explain a bit more about it more?
Yeah, of course. Before I started off with my own implementation of this demo, I read through the official document website with all of the information that exists regarding what's there and what's not about SenseGlove's Unreal Engine environment. This is the official SenseGlove Unreal Engine handbook, where there's so much information about installing and getting familiar with what's there and what's not. So a specific section in this handbook is about rolling out your own hand manipulation system. And within this section, there's a section on OpenXR. And this is the section that I focused on, where I developed these features and functionalities from scratch, as mentioned here. And basically, the system, as Mamadou mentioned, includes simple grab and release system, but can be expanded to more complex interactions. So what I did
here, sorry.
Yeah.
Just basically to add to what Apoorva said, on this table you see the new OpenXR system that we, I guess, delivered at with version 2 or 2.1, I guess. With this system, you will be able to use SGPON, use the system that basically Apoorva did with her demo, like consuming the raw OpenXR data from SenseGlove, or you can plug that and feed that OpenXR data to, for example, other plugins, which one of the famous ones is VR Expansion plugin, which is also a winner of Epic's Mega Grant. It has been, I guess, in development for more than 10 years. We also have an integration for that. You could find it on the documentation or any other OpenXR compatible plugin. But what we were missing in our demos was basically this demo that Apoorva has done. But before you continue, one more question. Did you go through the document, like the whole thing, because I guess it's around 500 pages when you export it as a PDF, or no, basically you just went through this section, or maybe because the thing is, maybe like not everyone have the time to read 500 pages, but what helped you, basically which section you recommend to our audience to read and basically do what you've done very quickly?
For me personally, this section was the most helpful because I understood what exists and what doesn't. And beyond this section, there was also some videos on helping me to get started with OpenXR specifically, because my interaction system focused on OpenXR itself. The tutorials within 20.3 were really helpful for me to get started with what's expected of me, to the basics of what's expected of me. But beyond this, also trying out the SGPON interaction system itself within what's already built was helpful for me to understand what's expected as a deliverable at the end of my project. But apart from this, of course, I did go through section 12, for example, to understand the plugin and more about how it's configured, and a general understanding of how SenseCom should be installed on the Windows system also really helped me, because I haven't, like I said, used a haptic glove before. But beyond this, I think the most helpful section for me was section 19 and section 20, where I understood the different components of the plugin and how the gap can be filled in with my project. So I started off with watching these YouTube videos here, introducing virtual reality, OpenXR hand tracking, and also putting in a virtual hand mesh animation to my development. So these tutorials were really in depth, I can say, to help me get a ground understanding before starting and move quicker to the development phase of my interaction system. And so should I move forward with the Unreal Engine development then?
Sure, thank you.
Yeah. Okay, so that was basically everything with respect to the web and what's out there. But now more on what I did and where my project started off. So to start off, the main requirement was to have something to some sort of interaction mechanism with the fingers of the hands. So what this means is when you are interacting with them. Yeah.
Could I interrupt you because you just like jumped into the blueprint? Could you first give us the maybe overview of your content browser? Go to the main map for example, see which files did you created, like the blueprints, or like maybe give an overview. This project, did you create it from scratch, or is it based on the template, VR template that comes with the Unreal Engine?
So for the objects and the table used in this environment, it's from the VR template itself. So the height of the table and the height of the pawn was everything based on the VR template itself, because it was simpler to start with that. But the customization of the baskets, the text box around and everything is completely from scratch. And also the idea of arranging objects in a given task within this environment is from scratch. So how this started off is I first created different folders for different reasons. The mannequins folder is for the hand mesh and for the hand itself within the environment. And the OpenXR framework is the folder where different materials, different objects, and also these blueprint codes exist. So within the blueprints folder, I have multiple blueprints where, as you saw here, the basket itself is one blueprint, which serves the purpose of catching the cube that I throw, which I will get to later. The instruction cube, the instruction blueprint is the basic instruction provided behind to build the pyramid with the blue cubes given. The instruction for developers is to replace these cube objects with whatever the developer wants to include instead of the cube. The instruction for users is to understand what to make of this environment and what to do in this environment. The BP OXR pawn is the main OpenXR pawn blueprint where the entire framework of this interaction system lies, which I will get to next. But before that, the egrab state enumeration file is basically to define the state at which the grab or release system is at, which I will again explain in a second. So as I said, the blueprint for the OpenXR pawn starts off with creating some basic functions and creating some sort
of... So basically, all the code is here, or most of it is here? Do you have any other blueprint code in the system that is elsewhere, or no, everything is inside this pawn class?
Yeah, everything is inside this pawn class. All of the interactions, all of the settings.
So if people want to make modifications, they can find all the code that you are going through in this one.
Yeah, everything is here. Everything that you require to edit or change or anything at all, everything is within this BP OXR pawn blueprint.
Yeah, thank you.
So, like I said, it starts off with creating a general mind map of how this flow of interactions have to take place. So what I did...
May I ask you, sorry, to zoom a bit more, because we are inside the Google Meet. Maybe you see it clearly, but for us, it's just a bit like too small, the font. Yeah, thank you.
Sure. Before getting into the blueprint code, I just want to say what helped me was to create a general mind map of these different interactions that were used within this environment. So the most basic requirement is to be able to pick up an object and to be able to release it. So in real life, to be able to pick up this object, we don't really have any sort of colliders or any sort of projections from our hand. But within a VR environment, we require some sort of projection which interacts with the object in the VR space. And these projections were called ray traces or line traces. So within this update ray traces function, which I defined myself, is where I defined these collision projections from the hand. And so what's going on in this function is that each finger of the hand has some sort of a projection, like I said, called the line trace. And this line trace interacts with the object that is present in the VR environment. And when there is some sort of a meet between this projection and the object, it tells the hand that the object is ready to be grabbed. So the idea here is that the logic here is that the interaction, the grab interaction, depends mainly on these three fingers. This was taken with inspiration from the SG pawn, which exists previously. And so what happens is that when the thumb and the index finger, or the thumb and the middle finger, have some sort of hit or some sort of an interaction with these objects in the environment, it fires something called the can grab function. And so this can grab function is where the check is happening, as I have mentioned here. The thumb hit actor and the index hit actor, or the thumb hit actor and the middle hit actor, are being checked if they are hitting the same object. And if they are, then it returns that specific object that is being interacted with, along with the component of that object. So it's both the actor and the component that's being returned within Unreal Engine environment. And this returned value is then used to actually perform the grab. So when performing the grab, the can grab function first checks if it is even possible to be able to grab the object and returns the specific object that is ready to be grabbed. Now, this entire functionality is written separately within the event graph for the left hand on the top and the right hand on the bottom. But please note that the function is not duplicated. It is only the same function that is written for both hands at once, but used separately for the two hands in separate graphs within the event graph.
So you made those functions reusable, like can grab or can release is general, and you can use it on basically left or right hand. Am I right?
Exactly.
Yeah.
Exactly.
And just before we continue, because you jumped straight to the basically ray tracing, why did you choose basically ray casting? Sorry, not ray tracing. It's something with the rendering, ray casting. The thing is, probably, I guess, if I remember, you first tried colliders. Why didn't you use colliders and prefer to use ray casting instead?
So, like you mentioned, colliders were also used in the SG pawn environment, and upon using this, I realized that there were multiple errors when the colliders were interacting with the, not errors, but they were not functioning with high performance as expected when interacting with objects in the space. And for this reason, line traces were much more direct and were much more straightforward, in the sense that these line traces were programmed to just detect the grab when these line traces hit the object itself. It's more straightforward and more convenient to port this interaction into a grab or a release when compared to the collider. And so line traces were used. And when using these line traces as well, it was a bit more of a calculation that was specified within this function, wherein it was important to mention the exact socket rotation, the exact socket location, the vector at which the ray trace had to be rotated, because by default, this line trace is not displayed perpendicular to the hand. So as you saw in the demo video earlier, the line traces were exactly projecting out of each finger at a perpendicular angle to each finger. So this was all done using this functionality where the hand mesh was passed in, the socket name, which is where these line traces are located. So the socket at which the index is located was where the line trace was drawn for the index finger. The socket for the middle finger was where the line trace was drawn for the middle finger, and so on for both hands. And so after these calculations were performed, the line trace was successfully perpendicular to the finger. And the trace distance here is a variable. So what this means is that the line trace drawn out of each finger can be of different sizes based on the requirement of the developer. In my case, this trace distance is set to 1.5. And if you increase it to, say, 3, then the line trace would be long up to 3 units in Unreal Engine.
So it's 3 centimeters or 1.5 centimeters.
1.5 centimeters and 3 centimeters, exactly. 1.5 seemed enough for the objects that I tested with, but you could, of course, experiment with that and see how you prefer that to be. So this is basically the calculation part to get the ray traces to work. And this is the main function which is drawing this line trace, where in the beginning I'm ignoring self, which means I'm ignoring the pawn itself when interactions are going on, because I don't want to interact with anything but the objects. And hit is where it actually detects when the object that is being interacted with this line trace is being hit. And accordingly, I have some branches, which is an if condition, to see if the hit is indeed what I want it to be. I use something called a switch on int to use the index value of each finger. So in my case, 0 is for thumb, 1 is for the index finger, 2 is for the middle finger, and 3 is for the ring finger. And here, accordingly, based on what is being hit, I am passing that value of the actor to the respective variable for that finger. So for 0, it is being saved into the thumb actor, for 1 to the index, for 2 to the middle, and for 3 for the ring. And accordingly, this hit variable is being returned in this function, which is then used in the canGrab function after proceeding from drawing the line trace. This feels like a lot, but when you see through the code and the comments in each code, it's going to be much more simpler. And like I mentioned before, the canGrab function is where it actually checks if it's possible to perform this grab when either the thumb and index or the thumb and middle are interacting with the object placed in front of the player. So for example, if the canGrab function says true, if it says it can grab, then this value of the actor and component that is ready to be grabbed is saved into another variable, which is specifically for the left hand here. So the functions are all reusable, but here there is a variable specific for the left hand so that there is no overlap with anything saved for the right hand later. Respectively, the same thing is also done here, where it is saved separately for the right hand after canGrab is checked for the right hand. After this is done, it moves to something called perform grab. And perform grab is where the grab is actually taking place.
So till here, basically what you did is just you are investigating the conditions, whether a grab or a release basically can be done, right?
Yeah, correct. Okay. And maybe it's good for me to mention this eGrab state that I mentioned previously, which is the grab state that it detects before even calling any of these functions. So this eGrab state variable has two variables within itself called released and grabbed. And what each of these variables are is that released checks if an object in hand is being held or not. So it returns true if an object is not being held. and grabbed is returned when an object is being held. So it's basically just a state machine which sees if an object is grabbed or released. So of course, when an object is released, you are ready to grab it, and so can grab is called. When an object is already grabbed, you are ready to release it, and so can release is called. So like I mentioned before, after the can grab, check is done after the actor and component accordingly is saved. It calls the perform grab function. So for this perform grab function, it is important to also include the haptics component, which is essential to give you that realistic feel when you're holding the object. The haptics component is first passed, and then the grab state, like I mentioned before, if it's released or grab is passed. The can grab value is passed to check if it actually is ready to grab or not. And of course, the hand mesh, which is being used, which is right in this case, or in the case of the left hand is going to be left, is also passed into this function. Within the perform grab function, the initial checks are just the basic checks where you see if the hand is being tracked correctly, if the object to be grabbed is valid, and so on, which is self-explanatory. But the core of this function is to see where this grab has to be done and how this grab has to be done. So to check where this grab has to be done, there is a function called getGrabReleaseSocketName. And in this function is where the socket name where the object has to be grabbed is entered. So what a socket is that it's a point on your hand mesh at which the object is basically clipped onto. So in my case, I have cubes like I showed in my environment, and these cubes are being set as cube grab socket left for the left hand if the left hand is being interacted with. So cube grab socket right for the right hand if the right hand is being interacted with. And if it's in any other case, then no socket is returned. So basically, after the socket name is provided to the function, it sets the physics of that object to false. So this object becomes static and is ready to be grabbed, basically. After this, a function called generate haptics is used, where the haptics for the specific glove is ready to be activated, basically. And after that, the specific actor or the specific object that is ready to be grabbed is passed into this function called attach actor to component, where that object is attached, or in this case, the location rule, rotation rule, and scale rule is snap to target. So this means that the object is just snapped to the hand of the hand that is being used. After this, of course, the object is already grabbed. So this means that the eGrab state has to be set to grab. And so it is set to grab. And accordingly, this value is passed on to be returned as a value of this function. So once this value is returned, it is saved to the left grab state, which is specific to the left hand, or the right grab state, which is specific to the right hand after the grab is performed. And now that a grab is already completed, the can grab value, which is the Boolean value, is going to be set to false because you cannot grab anymore and the hand has already grabbed something. So now this is a general understanding of how an object is grabbed. But what do you do when an object is grabbed and you want to release it is the next question. So that's when this comes into picture again. I'm sure you remember that we just set the grab state value to grab. And so this switch on eGrab state returns this side, which is grab side, and it moves to the function called can release. So the idea of the can release function is much simpler. And now that you understand the can grab function, the idea is just to let go of the object after you are holding onto it. And the condition is similar to what is going on in grab, but in this case, you will be checking if the thumb and the index finger or the thumb and the middle finger are not interacting with the object. And accordingly, you will also be setting the respective actors and the components to null, because you don't want any associated value with the object that is grabbed, and you are ready to release that object, let go of that object. So after this is completed, and as you can see in the function that I just showed, the actor to release is passed on as a return value of this function. The same check happens if the object is ready to be released, and if that is true, and if the object that was grabbed previously is the same as the object that is ready to be released. This is an additional check that I have done just to ensure that there is no misunderstanding within the Unreal Engine blueprint itself. If all of this returns true, then it moves on to the actual function where the release is taking place. And again, like the perform grab function, you have to let go of the haptics that is being simulated on the glove. You have to stop haptics here when you release an object. And the grab state, the Boolean value, the hand mesh, and also the object that is ready to be released is also passed into this function. So what happens in the perform release is again an initial basic check of conditions where you see if the hand that is being passed is valid, if the mesh that is being passed is valid, if the object that is ready to be released is valid. But this is the main section of the function where the detach happens and where the release happens. This is where the location, rotation, and scale rule is set to keep evolved. So what this means is that the scale of the object as it is in the world of the virtual environment is retained, and no other changes are made to the object to maintain that state of the object. After you pass the object to the detach from actor function, you also pass it to the simulate physics function, because if you can remember, we set the physics value to false in the perform grab function. And so here we have to set it to true again, because you're no longer holding on to it. And accordingly, also we have to stop haptics. So in the perform grab function, maybe I forgot to mention, we have a function called generate haptics, which is the main function used to be to generate the haptics that are used within this grab or release functionality. So this is a very basic haptic setting that I took from inspiration from the SenseGlove documentation, where it is explained much more in detail on the website. But in essence, there are something called levels, and these levels are just the intensity of the force feedback that you want on your glove. And accordingly, the hand is passed in, which hand you want the feedback to be enabled on. You send the haptics, and you mention where you want the waveform to occur. And in my case, I want it to occur in the whole hand. You can always change it to whichever tip of whichever finger you want it. And accordingly, you also set the waveform, the values, and the wave type that you would require for the haptics. This is basically what's going on with generating the haptics, which are then stopped after the object is released. And then to finish it all, the hand state is set to released because you're not holding onto the object anymore. And then this is passed on to the grab state, and the respective objects are set to null. So no object is grabbed, and can release is set to false because you can't release anymore. And the object is, released.
Yeah, thank you very much for the explanation. I guess you went just through the hand interaction system part, like grab, release, adding haptics. But as a person, like imagine I'm someone basically coming to the SenseGlove ecosystem. I don't know much about, for example, hand interaction systems. Probably I want you to step back a bit and basically tell us, I mean, you don't have to go to detail because we already documented that part, like in the documentation, but in general, I want to know, for example, which steps did you take to create this whole demo? First, you learned the OpenXR data format, then animated the hand and added haptic, like hand interaction system. What did you do? If you mention those steps and show us the code, actually, maybe I appreciate it if you still share your screen, just like an overview. You don't have to go to detail, because probably the most challenging part was this part that you went through in detail, but the other parts, maybe you could just provide a brief overview of the steps that you took to create this whole demo.
Yeah, of course. So as I mentioned before, I followed the videos that were on the SenseGlove documentation to be able to enable my hand mesh and the OpenXR tracking data. So watching those YouTube videos led me to coming up with these functions here, which is updating the visibility of the hand, drawing a debug virtual hand for the left and right hand, which is just a skeleton for the left and right hand in case you have to debug something, which is also explained in detail in that YouTube video. And also updating the left and right hand animation for the hand mesh itself. The YouTube video that was there on the Unreal Engine documentation website was very helpful and has explained everything in detail. And that's where I started off with to build my base for my project. After that, I, of course, did some reading on the Unreal Engine website and the forum, Unreal Engine forum, to understand what it means to have ray traces and what it means to have colliders. And like I mentioned before, ray traces were better. So that's where I dive deeper into how to implement these ray traces. Epic Games also has detailed documentation on their website for Unreal Engine 5.7, where they explain how each of these inbuilt functions are useful for specific reasons. So for me personally, it was first starting off with following the YouTube video from the Unreal Engine documentation website, and then moving on to the Unreal Engine 5.7 website to see what was possible with whatever is out there, and creating a map for myself and then using one at a time. I also did, of course, use AI to an extent to understand the overall flow of how things work with blueprints, because there are a lot of inbuilt functions out there and it might get overwhelming to implement all of this. So I would advise you to use AI only to guide you, but not to help you with building the blueprint itself, because that should completely come from you and the logic.
Could you also tell us how long did it took for you to develop the whole demo and each part, for example, like, because I mean, the whole system seems intimidating from someone that has never done this. Like, for example, what is OpenXR? Like, it has a specification. Maybe I have to read 1,000 like pages of technical data. Then, for example, like beside that, also how to animate a hand mesh, that gets very technical via code, and then these ray casting and stuff like that. It sounds very intimidating, but could you tell us, for example, which part was the easiest, which part was the hardest, what challenges was there to understand it, and how did you break down the basically task to just tackle it, like in a way that basically, I guess it took you almost 3 or 4 months from what I remember, but of course you know it better, to do it like in such a limited time, like going from zero, knowing nothing about haptics, OpenXR, to basically creating a like fully functional hand interaction system.
Yeah, of course, it was indeed overwhelming to get to where it is now. And as you mentioned, I haven't done this before. So I think for me, was the question more on how I approach this?
Yeah, how did you break it down? Was it really intimidating? For example, the OpenXR specification, did you have to read the whole specification or no? Basically, I mean, it was easy to pick up, or how did you basically manage to tackle that? I mean, that's just like the first thing comes to my mind as a person who wants to approach this. But of course, there are other challenges, as I said, like animating a hand, for example. You
Yeah.
probably never animated hands before, right?
Yeah.
So I appreciate it if you could help us understand what did help you to, do all these, like put together all these like puzzles and create this system.
Yeah, I think for me, probably the easier part to start off, because I have more challenges than easier parts. The easier part was to understand how the interaction takes place. So I just knew that we would, as humans, grab or release objects as a very basic interaction. But really building this in VR was a challenge because everything is, you basically have to design everything from ground up. And it really helped me when Mamadou, made this a story. For me, in the beginning, trying to understand this with parallel examples of something else. For example, it really helped in first building a very basic layout of the same thing with multiple other examples and then bringing it in to this. For example,
Could you elaborate
I remember.
more? Yeah.
Yeah. For example, I remember you gave this very clear example about a library system where we discussed about how a book is either borrowed or given back. So this system really helped me in
So
creating a
it was
picture
about
in
the
my...
finite state machine, FSMs.
Yeah,
Yeah.
exactly. It was the finite state machine for me to understand how that works, as I haven't developed that part before specifically. Understanding how and when these states are set to borrowed or given back. So it really helps to create some sort of small examples for yourself before jumping into the complete system itself. For me, maybe the biggest challenge was getting all of this in one smooth interaction, because I did have some challenges where when I grabbed something, I wasn't able to release it. Or when I released something, there was some sort of a glitch where all of the functions were running on infinite loops. So I think to not complicate it for yourself, it's easy to create a flow of how things should work and stick to that flow and not include multiple variables and multiple functions more than required. I had a variable for everything, I remember, and a tiny function for everything, but through time, I came to optimize it and remove these extra functions and variables, which were actually not at all required.
Yeah. Thank you very much. And basically, are there any other challenges that you faced? And what did you take away from this project that could, for example, help you solve like complex projects like this one, for example, creating these hand interaction systems?
Yeah, I think this project was a very, for me personally, I think this project falls under the domain of creative technology. And I am quite ambitious about pursuing my future path as a creative technologist. And so it really helps someone who is very interested in thinking about the creative aspects of everyday interactions and also really building them in the VR space, because VR can be as similar to reality as you want it to be. So I think those were the most interesting parts for me while building this project, to try and make it as seamless as real life. But of course, it's quite hard and time consuming. So given the time frame, this was what I was able to develop.
Yeah. I mean, your work were remarkable, and I personally am very satisfied with this demo, because basically this was something we were lacking for people who were getting introduced to the SenseGlove stack. And I guess with this help that you provided, and also being here today to walk us through it, I guess that helps probably our clients a lot. And I mean, it's just not our clients, because the SenseGlove OpenXR plugin actually is like a drop-in replacement for the default OpenXR plugin by Epic that is shipped with Unreal Engine. So they could be used as alternatives, and also other people probably could use your project as something to get started even without basically the SenseGlove hardware. So thank you very much. I guess that wraps up today's walkthrough, unless of course you have anything to add in terms of the technical things that you've done. So Apoorva, thank you for taking the time to share your work with us and walk us through the demo. It was great having you with us. Before we wrap up, do you have final thoughts or advice to anyone who is interested in developing OpenXR-based hand interaction systems with or without the SenseGlove plugin? We appreciate it if you have any opinion that you could share with us.
Yeah, thank you so much for all of the feedback. For me personally, YouTube really helped. So I think it's really helpful to completely use all the resources out there, because there are so many resources out there, and not rely on AI. I've personally seen many people who completely depend on AI for development, but it's really satisfying when you do it yourself and use resources other than AI for this purpose. So that would be my advice, to keep that creative juice in your brain flowing and continue development, because XR is a really exciting and growing space.
Yeah, I do agree. Okay, thank you, Apoorva, and also thank you all for watching. If you have enjoyed this video, don't forget to like, subscribe, and provide us feedback via the comment sections.
Thank you so much.